Okay, so this lesson we're going to talk about six. It's covering 6.2, which is all about trigonometric applications. So how do we apply? How does this work for us? So find the six or find the right triangle. Find the side x of the right triangle given below. So here we have a right triangle. What are the things that we have? We have a hypotenuse, we have x, and we have an angle. Now, how is that x related to the angle 50 degrees? Oh, well, that's the adjacent hypotenuse. So, according to SOHCAHTOA, or Oscar had a heap of apples, we can use cosine. So, we can say, okay, we're going to do the cosine of 50 degrees is equal to IDK out of 10. Okay. And then I'm gonna cross multiply because I'm gonna put this over 1. So now I can go, I can just go x over that. So then I have 10 times the cosine of 50 degrees is equal to x. Now, if I'm going to punch this in my calculator, I'm going to put it in as 10 parentheses cosine of 50. Okay. And when I do that, I get x to be approximately 6.4. So that is how you would do that one. Let's take a look at another one real quick. So this one is find the side x of the right triangle given below. So go ahead and take a second. Think about see if you could set it up before I do it. So what I did is I set it up as tangent of 22 degrees because that's what I have, and it's the Oscar had a heap of apples. Oh no, I didn't. Um, that wasn't tan. I did the sine of 58 degrees is equal to x over 24. And then that I have x equals 24 times the sine of 58 degrees. And when I punch that in my calculator, I get x is approximately 20.4. So that's pretty easy to do, right? Cool. Here is one more. Let's find the measure of angle theta in this triangle below. So crazy. I could actually use anyone I want. I can use anyone I want because I have all the parts. So I'm going to use sine. If I use sine, sine of theta if I use the sine of theta equals 5 over 13, I could use the cosine of theta, which would be 12 over 13. I could use the tangent of theta, which would be of apples, 5 over 12. I could use any of those. But the problem is how do I get the angle? Well, the angle you want to do is you actually want to do the arc cosine of 12 over 13, or the arc sine of 5 over 13, or the arc tangent, which would be 5 over 12. The arc is the second sine, second cosine, or second tangent. So that's what you would hit to do that. Regardless of whichever one you use, your theta should get you 22.6 degrees. Make sure your calculator is in degree mode. Make sense? Cool. All right. Let's move on to another one. Let's see if we can find the theta here. Which one are we going to use? Well, I know that the tangent of theta is going to be 12 over 5. I know the tangent of theta is going to be 12 over 5. So if I take the arctan of 12 over 5, I'm going to get theta, which is approximately 67.4 degrees. That's a cute angle. All right? Easy breezy. All right, so now we have this. This is similar to one of the problems that we did in the pretest. It says solve the right triangle shown below. So I have, first off, I can get theta real easy. I can get A and I can get B. So here's how I'm going to do it. First, I'm going to start out. I'm going to take the sine of 20 degrees, and that's going to be equal to A over 101. And when I do that, now I cross multiply. I got A is equal to 101 times the sine of 20 degrees. So let's go ahead and calculate that real quick. And I get A is equal to 34.5. All right. Now let's go ahead and I'm going to use cosine because I can get B now. I'm going to go cosine of 20 degrees is equal to B over 101. And so then now B is equal to 101 times the cosine of 20 degrees. And when I do that, I get B to be about 94.9. That is the worst 9 I've ever seen. 94.9. Okay? Now, how do I get the theta? Well, that's really easy. You can get theta by just doing the angle measurements. You could just do what is 180 minus 20 minus 90 is equal to theta. So 180 minus 110 is equal to theta. So theta is 70. So you've solved all parts of this triangle. Easy? Awesome. Now, let's solve this one. So this is actually, you can do this. This is pretty simple. Let's look at what we got. Oh, this is easy. What kind of triangle is it? It's an isosceles, right? So off the bat, theta is 45. Beta is 45. And side C, well, side C, that is going to be 8 radical 2. You got this stuff. This seems pretty easy. Let's move on to more advanced technique. Wheelchair ramp is 6 feet in length that makes a 4-degree angle with the ground. How many inches does the ramp rise off the ground? I have no idea. Well, here's what I would do. I would draw wheelchair ramp. 6 feet in length. Makes a 4-degree angle with the ground. There's the ground. There's my 4-degree angle. Not 40, because that'd be real steep wheelchair ramp. And if I make it, it's going to be 90 degrees. So how many inches does the ramp rise off the ground? This is key because this is feet and this is inches. So this is 6 feet. So what we need to do is we need to convert 6 feet. We need to convert 6 feet into inches. So or the other way around. So let's just go ahead and just do 6 feet and we'll figure out what x is. That's how high it goes. So we're going to do sine of 4 degrees is equal to x over 6. And then you cross multiply so you get x equals 6 times the sine of 4 degrees. So x is approximately 0.4 feet. But they want that in inches. So how do you convert that to inches? You take 0.4 feet, and I'm going to times that by. There are 12 inches per 1 foot. Foot goes away, that's mumbo jumbo, so 0.4 times 12 is 5 inches. All right, sweet. Let's try another one. The angle of elevation from a point on the street to the top of a building is 53 degrees. The building is 60 feet high. How far is the point on the street from the foot of the building? So if I draw a building, something like this looks like a great building right there, right? There's my building. Okay, I know that building is 60 feet high. I know that from this guy to that guy makes an angle of 53 degrees. So that's still 60 feet. So I guess what I'm looking at is how far is it from here to here? So what is x? So what am I going to use to find that? I think I have I have opposite and adjacent and an angle. So I'm going to do tangent of 53 degrees. And that's equal to 60 over x. Cross multiply, I got x times the tangent of 53 degrees. And that's equal to 60. And I'm going to take and divide both sides by the tangent of 53 degrees. So 60 times the tangent of 53 degrees is how far I am. And that's approximately what did I get? I think it's 45.2 or something. But you can check that. Angle of elevation. That's what I want to talk about. Angle of elevation means to look up. All right, that's key. That's how I knew to draw that triangle. And the same thing as angle of depression. All right, let's see if we can do another one. While on a nature walk, a person spots a small oak tree with an angle of elevation of 25 degrees to the top of the tree and an angle of depression of 15 degrees to the bottom of the tree from eye level. The eye level is 165 centimeters. How far is the person standing from the tree? And also, how tall is the tree? And why are we talking about this? So what I would do is I would draw a tree. My tree looks more like celery. And then here's a guy. Going up to that spot right there. And it says, because that says eye level. So I'm going to go just like that. They said that that's 25 degrees angle of elevation. All right. So there's that. But it says that to the top of the tree and an angle of depression. So if the guy looked down, if he's looking down towards the tree right there, there's your angle of depression. Whoop. Sorry. Angle of depression right there is 15 degrees. He's X away, but then he's also 165 centimeters to his eye level. Right? He's 165 centimeters to his eye level. So how do we get this? Well, I want to figure out how far is the person from the tree. I can just really use this guy. I can use either one, the 25 or the 15. I'm going to go tangent. No, hold on a second. No, I'm going to use the 15 because that's the only one I got. So I'm going to go tangent of 15 degrees is equal to 165 over x. So then x times the tangent of 15 equals 165. So x is 165 divided by the tangent of 15 degrees, which gets me to approximately 616 centimeters away from the tree. Now, how tall is the tree? How can I figure out how tall the tree is? Well, that one, I'm going to use the other guy. That one, I'm going to use the 25 degree guy. I'm going to go ahead and say I'm going to do the tangent of 25 degrees is equal to y, they call that y, over x. Now I just found x. I just found x. But I'm not going to worry about that right now. I'm going to go ahead and do this guy here. I'm going to say that um, tangent 25 is equal to y over x. So y is x times the tangent of 25. Now, x we found right here. Now you can either use 165 over tangent of 15, or you can use the approximately 616 centimeters. I don't care which one you use. You're just going to your calculations will be a little bit off. So let's use the 616 times the tangent of 25, and that's going to get you about 287 centimeters. But we're not done, because that's this guy. We have to take that 287 and we have to add the 165 to it to get the 452 centimeters. So that's how tall the tree is. That's using the trigonometric application stuff. I know this video went a little bit long, but hopefully it makes sense. Take good notes, and I'll see you in class tomorrow. And may the 4th